Hello there, Mr. Sutton here, bringing you this lesson on the greatest common factor. In this one, we're going to be dividing polynomials by monomials to start things off, and then we'll move into taking out common factors, and we're going to factor by grouping, which is an extension of this common factor idea. For your warm-up, see if you can simplify this expression using only positive exponents. All right, let's see how that went. So we're going to end up with a fraction for an answer. And let's just go factor by factor here and reduce what we can. So 3 over 9, we can reduce that to 1 over 3. I'll put a 3 down here, and I could put a 1 up here if I wanted to, but if there's going to be other stuff up there, we don't really need it. Moving on to the y's, when we divide one variable by another that's the same kind of variable, we subtract the exponents. This is y to the 7 minus 1, and we're going to put the expression wherever the larger exponent was. So y to the 6th then goes upstairs. Next, we've got x to the 3rd and x to the 8th. That's x to the 8 minus 3, and we're going to put that downstairs because there was more x's downstairs. And what's really happening here, of course, is you could write out 7 of these y's and cancel out a y here. You could write out 8 of these x's and cancel out 3 of the x's. So that's why we end up with things where they are. For our next problem, we're going to divide a polynomial by a monomial. This is a good skill to have. So whenever you have a whole bunch of things being added or subtracted on top of a fraction and only a single term on the bottom, you're basically allowed to distribute division to each of these things on top. So you can essentially split this up into 3 fractions, each with a denominator of 4xy. So we've got 4x cubed y squared over 4xy, 8xy squared over 4xy, and also this 12 stuff also gets its own denominator. Now we're just going to go through and simplify each one. So simplifying the first one, 4's are going to cancel. We have x squared if we divide a cube by 1. And we've got y to the first power. This is 2 minus 1. Next, 8 over 4 is 2. X's cancel completely, and we just have y on top. So 2y. And for this last one, we have a negative out in front. Don't forget that. 12 over 4 is 3. X squared over x is just x. And y cubed over y is y squared. We're now at the main part of the lesson, which is taking out common factors. What is factoring anyway? Well, factoring is when you take a polynomial, like the one that we have over here, things that are being added or subtracted, and turn it into multiplication. Factors, in fact, is what you call things that are being multiplied together. So we're just changing the form of this. To do that, one of the most common ways to do it is to try taking out a common factor. In fact, this is always the first technique you should try whenever you factor an expression. So to take out a common factor, you have to first know what the common factor is. We're looking for the greatest common factor. So we've done GCF kind of reasoning before. Looking at 7 and 42, what's the greatest common factor of those? Oh, 7, because that's the biggest thing that goes into 7 and 42 without a remainder. We should also look at greatest common factors for the variables. These don't both have x's, so we can't take an x out of here, but these do both have a y. So they're both divisible by y. Y is a factor of both of them. So once you've found your common factor, you should try to make it the greatest common factor. We're going to stick it outside a parentheses. So we can put our 7y that we want to take out outside a parentheses. And what goes inside? Well, we're going to divide the expression that you're trying to factor by the factor that you just took out and write the leftovers, the quotient, inside the parentheses. So we're really just dividing a polynomial by a monomial again. This is just a different form that it takes. What's 7xy if you divide it by 7y? Well, the 7's cancel, the y's cancel, you just have an x. What's 42y divided by 7y? Well, that's just going to be 6. So x plus 6 is what we would put inside there. Now, if you're not sure if that you've fully factored this, or that you've factored it correctly at all, one thing you can do is distribute it back out to check. So 7y times x, that is 7xy. 7y times 6, that is 42y. So that's a quick way to check. All right, here's another expression for you to try factoring. Pause the video and try this one on your own. All right, so hopefully you came up with 8x as your greatest common factor. All of these numbers are divisible by 8. It's the biggest thing they're all divisible by. And they're all divisible by an x. Now we can only do x. We can't do x to the third or second because this last expression is limiting us. It only has x to the first power. If you try dividing this x by an x to the third, you're going to get a negative exponent or some kind of fraction. We want to avoid that. So let's go through now and divide each of these by 8x. First term is going to become x squared. Next term, that becomes a 6 and an x. And the last one, careful, we still have a negative. That's going to be 12 if we divide 96 by 8, and the x's cancel completely. And that is factored. Now, is it factored completely? Well, there are techniques you can use sometimes to factor the things inside the parentheses. It turns out there's nothing else we could do with this expression, but later on we'll look to do a little bit more with what we've left inside. Moving on to the last example of this type here. Pause the video and try this one out. Now, don't feel bad if you couldn't figure this one out. It turns out there are some polynomials that are what we call prime. This is something that is not factorable. Remember, prime numbers are only divisible by themselves in 1, and really the only common factor you could take out of this is a 1. But we're not going to bother taking out a 1. In that case, we just call it prime, and we're done. Here's another problem with a little bit more to it. Pause the video and see what you can factor out of this one. Okay, how'd it go? Not too good, huh? If you look at all 4 of these, there's nothing that comes out of all 4 of them. You may have noticed, however, that if you take a look at only 2 of them at a time, like the first 2 terms, there's some things we could take out of those, right? And the second 2 terms, we could factor some stuff out of those. Are we allowed to selectively factor out common factors? It turns out there's a whole factoring technique based on it called factoring by grouping. So if you see 4, count them, 4 unlike terms like this situation here, here's what you can try. You can try taking a common factor out of the first 2 terms and out of the last 2 terms separately, like so. So first 2 terms, what can we take out of here? Well, they're both even, so we can take out a 2, and we can take out an x. That would leave us with 3y plus 7. And the second 2 terms, we can take a 5 out of both of those, so that also leaves us with 3y plus 7. Now, if you have the same thing in both parentheses, you don't always, but sometimes you do, you can actually treat this 3y plus 7 as its own big common factor. And just like any other common factor, you can factor out this duplicate parentheses from the whole expression. So if you factor out that repeat parentheses, that means you get to put the leftovers, 2x and 5, in another parentheses. So we're factoring out the 3y plus 7, and this is basically like if you just divided each of these by 3y plus 7, you would put the leftovers in parentheses, just like any other common factor. So 2x and 5 is all that would be left over. And this thing actually is now factored. Kind of neat. Here are 2 more for you to try out. These do have a few tricky things in them, which is why I'm giving you these as problems as well. But pause the video and let's see where we get. Okay, so for this first one, we can definitely take an x squared out of those first 2 terms. So that's x plus 5. So far, so good, hopefully. These next 2 terms, you could either take out a 2 or a negative 2. So which should we do? In general, it's a good idea to take out a negative when you can so that it doesn't come back to bite you later. I'm going to take a negative 2 out. That'll leave me with an x. And we got to be careful here. When you are factoring out a negative, you need to remember to reverse both signs in the parentheses, because remember, you're basically dividing both of these by negative 2. So negative 10 over negative 2 is plus 5. And the added benefit here is that, hey, it's the same as the other parentheses. Since we do have x plus 5s repeated, we can factor those out and then put our leftovers, x squared minus 2, in a parentheses right next to it. Now let's take a look at this next one. So for the first 2 terms, we can again take out an x squared, leaving us with x plus 4. And for these next 2 terms, well, it doesn't look like there's a whole lot that they have in common. We could take out a negative. In general, you can always take out a 1 if there's nothing else. And to make these problems work, that's often what you have to do. So if we take out a negative 1 then, that's going to leave us with x minus 5. And now you might be wondering, did I do something wrong? Notice that we've got different parentheses here. And if you've been just kind of writing the duplicate parentheses over again without really understanding what's going on, you might be tempted to just kind of pick one of these, write it down, and put the leftovers next to it. But when we write this duplicate parentheses, remember, we are taking out a common factor. They have to both be the same, or this is mathematically wrong. So if you're forced to choose between these, then you can't really choose at all. In a situation like this, it turns out you cannot actually factor it with grouping. And hey, that's okay. We were never guaranteed when we started that any of this was going to work. It just happened to work out in some situations. So if you get here, there's something else you're going to have to do to try to factor this, if it can be factored at all. So don't force it. So we've seen in this lesson that sometimes grouping works, and sometimes it falls flat on its face. How can we tell what's going to happen before we actually start the problem? Like if we have this situation here, how do we know grouping is going to work? Pause the video and see if you can come up with a test, and then we'll bring it back together. All right, so here is the idea. It helps if A and B are in the same ratio as C and D. If A over B equals C over D. The idea here is you're going to try to factor something out of these first two terms, and this A and this B are going to reduce as far as they can, at least if you take out the greatest common factor. And you're going to do the same thing over here. You're going to factor something out, and C and D are both going to get reduced as far as they can. Now, for grouping to work, whatever A and B gets reduced to has to also be the same numbers that C and D get reduced to. So if these two ratios are the same, and you see that in the very beginning, you know grouping is going to work. Well, that's it for this one. Until next time, this is Mr. Sutton signing off.